你选的话是企业做的，私有的话，还有一张表是有
This is a test of the emergency streaming protocol. This is only a test. This is a test of the emergency web streaming protocol. Should you be in a Meteor Devshop, grab your flotation device and hang on.
细节恢复，就是怎么调到这张表，调到那个。
开头强制的，就最这方面东西，东西要少，一定要大的然后之后的话，然后 update 的话，我就不再去那时候，我就直接开始抓我的情况。
那么现在的问题就是，一开始3 up 的时候就要区分我是企业和个人，那那个3 up 的那张表。
This concludes our test.
盘子是可以的，对，不是，还比我可爱，还比更难听，
为什么？
对，
小号是唯一吗？
对，小号的，表盘要少150块，这个字，表盘要少一点，女生的。不是在网上还有个人，表带不一样，然后另外我已经都看错了，它这个是最贵的那个，然后再有专科外，然后还有金外的，10万人民币。如果漂亮的话，它是跟美国一样做那个，它有个功能，对，震动功能，你可以尝试一下，它那个美元那边也会震动。OK，就是这玩意儿，这个没有，我先说这个不能拍视频，这个不能拍到，因为它没有这样。这个你可以干的话，可以打电话，可以根据手机中心看 GPS 看一个很小的 map，然后别人这样没用，然后还可以这个2清理，就是说用2清理。如果你是如果你 Siri 的声音的话，你会带着很大的能力。用手刀为了防止你的手腕受伤，不会把手腕包起来，手腕包起来让它受伤，然后如果说我不接这个东西，那我的 target 会做不同类型的东西，然后我先从我往上跳一跳，让它只能一种比如这个 model， 然后我之前就这东西用的我讲找到那个样子，对这个业务的时候买。这就是显的，对，我觉得这是唯一的必须，就是2个还100万通过手表来跑一跑，我觉得这是唯一的必须。这是一个通对，微信客户信息，微信是正好就是说 notification 就是因为微信是支持语音的，然后这样的话我觉得可以。你让我看一眼你的 WeChat app 在上面会显示什么样子？这个东西给你带，它拿出来是会这里面要给你演示，我到现在没玩过，因为它拿下来你就没法带上那就不让你输入了。就一站的它就是识别它的手还是一样，有一个 security 的东西，原本的那种设计。
对呀，我们试了2个产品，最后还到第3个产品去采访。对。
所以应该先去这个工作室。
这样子我就要开始对我的体重开始那个，我现在已经很久没有去，我以前每天都去游泳，现在我1个星期才能去游泳2-3次，一般都是晚上去游泳，去上完课早上去游泳。
太晚了，我们上次在游泳池。
游泳其实帮你有氧运动。
我想问一个算法，就是说这件事的出处，我要到那头报人，就我们就谈的是，我只是这样报人，你让他报人，根据这个人脸来看他的表情。这件事难做吗？现在算法不是。效果，说主题。然后看那个是这样子的效果，这样子的。是不是真的不效果？就是说我就想做一个很好的，就是
拍到你这个照片，长得一直
在这儿。吃了它的，这么买了拿了3个。还有一个，这。还有一个。
在内部的话，
他们写出来，
这有什么可改的？就是能力不一样。
是右上。
你稍等，其实我现在我记得应该是最多应该是上次只是到现在没有一个时间点。这个其实是邮差过的，邮差过没有在之前，我下面看到什么，或者说可能是包括都会做发酵的。我觉得他们算法非常简单，就是比较前后的图照片的差异值大，或者说差别大，他们就可以支持他们的 车。我也开车回来了。你大概什么时候回来？
我8点半之前，8点半之前。
哦，不是吧？然后咱们要听吗？
你们不是要听他们讲吗？你们要找牛人是吧？我就跟你说一个建议，你就听那些人讲，讲完了以后你觉得最牛的，然后就去找他。
就一个比较牛的。在哪？好，你有电话吗？来，坐过去一个人吧，没位置了。坐过去。霸气的位置。一般上去讲一下。我可以，你们觉得没有一个人作弊的？会马上往上直接会干。2演讲，还有2大演讲呢。CEO 要来。JavaScript state 国情咨文。看。其他的。加上微信号，在群里面吗？把微信加进去看。不用。哪个群？Twitter群。我算你们自己加呗。
你刚才通过那个问题，你知道他水平真的非常高，因为我听了2次，他比他比较开玩笑，技术上他有天赋，就是包括那个一反吗？对，不能说是一反，他也很厉害，能感觉出来。但是你要刚才那个的话，你还是要听他的，因为我觉得他可以跟我这样问的，他是在以前是就是说，不知道他们有没有给你讲过海军学院的教授，他是教授对吧？然后呢，他们专门做这样的。他这个人说话的特点是，他说他每次工作他们说没有人爱开玩笑，我说你这做的或者没什么钱，那可能你们做出来那个 product 但是一定是非常烂的，等你再走下一步的时候呢，你就很难从第一步，因为你已经做出来了，你会基于第一版烂的再慢慢去改，你还是听他的，他这也是要推一下，比我要强。
但是以来者，我们是想再做一个在创业上做一个这个大数据的项目 ，video 相关的。video。
那你可以让他就是刚才那个他叫什么名字 ？Eliza，可以让他帮你介绍一下那些真正的专家。
你在群里面吗？
其实不是我教的，是这个很好。这东西绝对好过
image submission 这块，deep learning 搞起来就非常贵。这个地方有个问题，就是它这个小心这个事情，它其实很大一部分呢，真正是绑效果，真正效果还是数据的相关性。
就是上课的时候，
比如说就是说你同样的月1号，同样的算法，我们
差不多的，但是如果有大数据在那儿测，然后它是直接给你数据。
做大数据的人就每家算都不太熟。那他们比赛就是有一个叫 Linting，Linting 是那个数据是固定的，就这么多数据，然后就放Facebook、百度、他们每天 deep learning 看谁识别率高，这样，那个是没算的，一样的数据。
这样我们就没办法，我们现在是拿因为什么？因为现在拿去玩完之后，但我们就用我们自己的 data， 然后我们自己 data 本来测完了出来的现在不是效果，一开始80，现在慢慢接近90%，但这个没有用，因为我们没有对手，你对手不知道是谁，你说90%，你用吗？你要不然你就用自己。其实90%你都错了，我以前拿那个，我当时想2去读像嘛，因为我是股票嘛。当时我跟导师说，要不然炒股，我导师特别想炒股，我说好，那我来试试。我能把这个东西当时还没有那个地方现在叫 variation of variation， 那写出来扣的准确率98%，好吧？股票一天上下波动多少？也就他妈2%到头了吧，123%吧，你根本没用，出来都是 noise。而且我们的 data 在过去传统我们只能拿到，就是说如果你要拿到 data， 你拿到1980年，好了，
但你不能 by minute。
by minute 没有，by minute 大概如果要是 Bloomberg 拿那个是说要很贵的钱，
拿到数据值。
对，但是就是拿到也没用，为什么？1980年到现在恰好是30年牛市，中间是 dip 了好几次，但是1980年到现在。
就是你让他，按照道理应该是往上走，但是问题是你只要能够这个成功的人，提前1个月找到一个大 base，
没有用，绝对是大 base 减很重要。所以说我们在炒股这个系统当中，最重要的一个东西叫什么呢？2个东西，一个叫做 Sharpe ratio，Sharpe ratio 就是说你这个东西有稳定的在赚钱。第二个叫 max loss， 你在最次的情况下，你不要把，因为钱没了就是没了，给你10万你没了，你想想跌成5万，你要再来翻回10万，你要翻1倍，但是你只要跌50%就下去了。所以说 max loss 是特别重要的。后来有这么一个地步，所有的年轻人都告诉你，已经地步了，可以买了，你买还是不买？你要知道今天它可以买，万一我又是地怎么办？万一凡是这种大地都是极小概率事件，所有的炒股都是这样，都是拼概率。我在比如说我现在做的这个东西，比如说超过3个 standard deviation， 99.7%开始去做，实际上就是前几天出现了连续跌了5天，对吧？好，你连续跌了5天，你说我赔没赔钱？一定赔钱。但是我事后因为我错了一次，我可以加倍，错一次可以加倍，钱是有限的，所以我一开始我就特别 aggressive。然后呢，我最多的时候我那个我可以错4，连错4次。那这个时候已经3个 standard deviation 再连错4次的概率非常小。万一出现了呢，911出来怎么办？我这个是没法说这个，所以说这种情况会不会反？如果3个deviation还可以连错4次，你说我的系统稳定吗？相当低，但是会出现。这是第二个，我真正做了一个系统，比如说 high frequency trading 的一个系统，你说我的 winning 和 loss 的那个 rate 概率是多少？答案是我做成55比45。对，就够了，因为就像老母鸡一样，high frequency trading 是说我去玩命的做，high frequency trading 对，就高频交易换大一点点，我就利用那个 T 的不稳定的状态，就是说我当时有一个理论叫做 efficient market theory， 意思就是说我市场是有效的，我长期为了利的市场，但是呢，在你把它 T 把它无限的分下去的时候，到某一个delta时间内是有这个 efficient， 我是可以不 efficient， 我可以捕捉你的市场，我可以先期让你去移动，然后我可以去 trading 那个。
我这块我接着说啊，就是说我能也简单的把那个推荐，就是我看了我几个加交易所，我发现每个交易所价格不一样，我觉得这种在我认为这是做交易所差价。
好，你说的这是大部分只有 Renaissance 才会玩的，因为你先下一个单，你到他那儿的时间我比你快，先付钱出去，这是第一。第二个，我可以欺骗市场。假如我 place 一个 order， 我用 option 去做就是100倍，对不对？好，我用 option， 我现在下个2000个单，20万的 underline 你搞不了，对不对？如果我不是下的 SPY 的话，我下一个小股票，20万的股票现在做一个 option 上，这时候股价就跳到这个点，我是知道自己可以的， 一上来第一个开测掉，然后把我的股票卖了，先买这个，我把你骗上来，我先卖掉，然后你再把这个测掉，我还是有我这个事先知道股票涨的这个钱，但是这点不重要，是因为我一定要确定后面这个单就是我知道它是然后下来这个然后把它卖掉，这有一个非常大的危险，我那个 open 是真的在那，如果速度更快的话，我真把这个单子吃进来，等于相当于我把你的单子给你拉高了以后，我买进来了，我要让买家你正在买，我知道你的单子比他的大，我先去加一个高的单子，让这个 interest 上去，让你被迫接受这个价格，我给你买掉，我再卖。用这种方式。
实际上就是庄家做，但是用电脑做。
对，而且我要一定要，就是而且是我骗你的，我骗了你。
而且他知道我们俩下单都是
我讲了慢一点再跟我说，我真的没有这个逻辑。我其实有一件很有理解，为什么我买一个 option 我会对这个股价会
因为他单大，
不100，
对，他买了20万，
如果买的是一个全量，将来会成为一个全
对啊，这个权利如果股价上涨的时候呢，我就这样但是我根本不要这个开出单，开一个20万
20万也就是20，OK， 20万手
，20万
手是100，
不，20万对。
OK， 看不看？你家 OK？这个家 OK？
我用一下我的这个，哦，要按照 passcode，那要不我就用我的。
市场上就认为说，现在 bottom line 就可以用这个 language 在这收，所以他就用了 language 在收。这个时候呢，他就会把股价，他把股价提高起来。那这是我骗他的。当他把股价提高的时候，股价就需要我利用我给他换，我就把它消掉就是他的，让他的单子变少，比如说他已经物价从1毛钱变1毛2，我事先我在下个单我就知道机会有，所以我在1毛钱买了这个股票，等它涨到1毛2，我赚的是2分钱，而且我没骗你。假如我事先知道这个股票会有1毛钱到1毛2，我要干的事儿，先买好了，现在告诉大家，大家不要1毛2收购，开始你没有开始跟着我在1毛2收购，我就把这股价拉到1毛2，卖给你，然后我告诉大家，我跑到一家鞋店，我跑到一家皮店去说，我要订个先订披萨，然后
Hey everyone, just letting you know that talks are starting in just over 5 minutes, so really excited for them today. A quick note, the talks are live streamed and recorded, and the audience, or parts of the audience, will be visible during the wide shot. So if you prefer not to be visible in the live stream, then please move to the back of the room or move to the upstairs room. So yeah, so we'll be starting in about 5 minutes, and please take this opportunity to silence your devices if you have not yet. Starting soon.
What happened to your name tag?
Sam usually asks me to take it off
Oh, okay.
when I'm speaking. I'm Alice.
Alice, Zhu, right?
Alice Yu, Y-U.
Why you?
Close. Okay, we're gonna get started. Wow, this is incredible, guys. It's like the biggest event that we've had in this office that I can remember. So I'm super excited, super grateful to all of you for showing up tonight. I'm really excited to welcome our first speaker. So our first speaker is Ben Newman from the Meteor core team. Before joining Meteor, Ben worked on React and other developer tools at Facebook. He has also worked at Meebo, Aperture, Mozilla, and Quora. A common thread that runs through Ben's career is a passion for exploring the limits of dynamic programming languages. And Ben actually represents Meteor in the TC39 JavaScript standards process. And he'll be telling you about ES 2015, which is the upcoming new version of the Ecmascript standard that the JavaScript language is based upon. Everyone, please welcome Ben.
Hi, thanks for that, Alice. This is better attended than some conference talks that I've given, so this is really great. There's a lot of energy in the room. I'm Ben Newman, as it turns out, and you can find me on most forms of social media as Benjamin without the I, in case you want to follow up on this. And what else can I say that Alice has not already said? Yes, I did work at Facebook. I've been at Meteor now for about 11 months, and I love it. Getting to do many of the same things, including being on the standards committee for JavaScript, that TC39 committee. Got to do that at Facebook and persuaded Meteor to become a member organization of the committee so that I could keep doing it here. So that meeting, actually the most recent of those meetings, was happening this week, and so that dovetailed nicely with some of the things I'm going to be talking about tonight. I feel like we have an obligation to try to explain what we find exciting about the work that we do, especially to people who don't have as much context as we do. And so I wonder if you've ever tried explaining Meteor without saying something about JavaScript. It's pretty hard. Most of our marketing material is pretty heavy on the fact that it is a, for instance, JavaScript app platform, that it is a complete open source platform for building web and mobile apps. That's all fairly generic up until now when we tell you that it's a pure, it's for building them in pure JavaScript. So there's something about this that is inescapable about what makes Meteor Meteor. And yet, you have to wonder what exactly you're talking about when you talk about JavaScript. It's a term that's been around since 1995. You may think of it as that language that runs in web browsers, the one that hasn't changed all that much since the early 2000s. And that's no longer a fair thing to say, but this idea is still floating around. If you know a little bit more about how JavaScript is written these days, and I'm sure most of you do, you may know that it is the language that puts the JS in node.js. But which version of Node are we talking about? If somebody really knows their stuff and you tell them that Meteor is a JavaScript platform and that it uses Node on the server side, they may wonder, if you're using version 10 or 11 or 12 or IO.js. How much of the standard library actually works according to the language specification, and which specification are we talking about? Can you run the same browser, the same code in a web browser? What kind of module system does Meteor support? What's the deal with fibers? Probably won't get that question, but you may be wondering, what is the deal with fibers? And if we take a step back, it is actually, I think, somewhat remarkable that all of these questions have definite answers. Anything someone could ask you about Meteor is a question you can probably answer at a technical level. That doesn't mean that the answer is obvious, but I like to say that one of the most valuable things about a programming language is that everyone, in principle, can agree precisely what will happen when a computer runs a program that's written in that language. And that's incredible because the other kinds of languages that we have, natural languages, certainly don't have that property. Everyone understands their own particular meanings, and you have to fall back on context or asking questions, having a dialogue if you don't understand what somebody has told you. But this property of programming languages means that computers can do their work very quickly, and you can write some code that solves a problem and give that code to someone else, and they can run the code and see that it solves the problem, even without understanding how it works. And if they do want to understand how it works, they can dig into it and answer that question at every conceivable level, because it is all so precise. So, although I hope I've sown some doubt about exactly what is referred to by JavaScript, I do want to clarify that that term still conveys much of the necessary information. It's still one of the most useful ways of getting across this important part of Meteor. Even though JavaScript may be a little bit vague these days, there's still a vast audience of programmers who know it by that name, and so we're going to keep calling it that for the foreseeable future. But programming languages change, and this is great news, because JavaScript used to be a language that people thought would never change, and that was the most depressing thing about it. And JavaScript is actually changing faster than ever these days. One of the ways that it is changing is that it has a new name, technically. The European Computer Machinery Association is the standards body that publishes the Ecmascript standard, which is how JavaScript is supposed to work now. And so they've given their name to the language. It's called Ecmascript. This is not just the second name of the language. It was originally called Mocha, or Mochascript, and then rebranded at the last minute in 1995 at Netscape to JavaScript, because that sounded like Java, as you may know. But now it's Ecmascript, and this seems here to stay. But more precisely, it is Ecmascript 2015, which may scare you if you're used to, say, Windows operating systems versioning and like still using Windows 98 in 2007. Like, that's a bad situation to be in, but I know that the TC39 committee knows that, and actually this is great, because this departure from sequential numbering creates a pressure, or at least signals an intention of the committee that they will release a new standard every year, because every year that goes by makes the name of the language look more and more dated. So this is a sign that things are picking up. It's easier than ever to propose new language features, get consensus built around those proposals, and this is a link, just in case you, I don't even know where that tab opened. Okay. There it is. Yeah, how do we get to that? So this is a list of all of the current cutting-edge proposals in their various stages of acceptance. If you've ever wanted to acquaint yourself with what's coming up, the TC39 repository on GitHub, ECMA 262 repository, it's where all that's stored. Okay, I hope I can, oh no, my whole presentation. Cool. Well, I'll take this opportunity to tell you that these slides live here, benjamin.github.io/devshop-july-2015. All right. Here's my little speaker slides. Great. I think we're back in business. Actually going to have to skip. Where were we? Right about here. Okay, those proposals, and get them implemented. As an example, the regular expression escape method was revived just last month on the ES Discuss mailing list and got presented in this week's TC39 meeting, and is almost at the level of being on track for standardization, which is amazing to me, because actually this was proposed more than 5 years ago for the first time on that mailing list. And so the TC39 committee has not always been able to turn things around this quickly, but now, within a month, they can consider a significant addition to the language and make progress on it. So this is all getting so much better. There are, of course, multiple levels of implementation of these ideas. It's not enough to just write in a standard that something should exist, although that's an important first step. After that, you might hope that transpilers like Tracer or Babel would pick up the feature and allow you to simulate it. Then maybe you would hope for native support in Node. That's good for us, because Meteor uses Node on the server side. So for server-side code, that would allow us to use new features perhaps more efficiently. And then native support will eventually make it into at least some browsers. And finally, native support everywhere is the goal that we're shooting for. But one of my arguments tonight is that that may be a long way off, and that's not a reason to worry. So our commitment at Meteor is that through a package called Ecmascript that we're going to be providing in Meteor 1.2, we're going to provide any and all language features that can be faithfully compiled to code that runs natively in all JavaScript engines. So if you think about it, there are sort of two kinds of progress here. First, Meteor might provide simulated support for some new feature of JavaScript that's been proposed but not implemented in Node or browsers. And so we're sort of pushing the state of the art forward in that direction. But then lagging behind that by maybe months or years, native support hopefully will catch up with the simulation. That's the hope, at least. So as long as what we are implementing are features that are destined to become part of the language, then eventually we will no longer have to simulate them. And we'll be able to transition to relying on native support. It may take a while, but it's sort of a double-ended queue of progress here. The principle that I'd like to leave you with, our sort of litmus test for whether it's worth supporting a feature, is that if we start supporting a new language feature, and trust me, there will be examples of this in a second. I know this is pretty abstract right now. If we support a language feature, like say classes, and you start writing code using classes, you should not have to rewrite that code when native support finally catches up, right? It's okay if there are some things involved in classes that you can't do yet. You just can't write that code yet and have it work. That's fine, because then you'll eventually be able to do that when native support gets here. But the thing we want to avoid is like luring you into doing something that seems okay right now, but then once the future is finally here, needs to be revamped. Okay, so we've been using Ecmascript 2015 in the code that implements the Meteor command line tool for some time now, and it's really great. So I want to show you an example of the kind of simplification that we've been able to reap with this new syntax. How great is it? Well, here is some code that defines something like a class called JS file. And I'm going to iteratively remove and rearrange parts of it to show you how you can successively apply Ecmascript features to make it simpler. Right? So what is it doing? There's a constructor function. It's invoking a superclass constructor, and then you're setting up the prototype chain, making sure that instance of works by assigning to the constructor property of the prototype. And then the class only has one method, add JavaScript. And it takes some options and does something with them. And then this is in a common JS file, so we're exporting the class so that it can be used in other files, right? So this is a fairly common idiom, as horrendous as it may be. And it's sort of a lie. We do have, at least right now, a convenience for the prototype chain stuff. So that can be replaced with meteor._inherits. But as you can tell, that's not exactly a public API. Right? So that's not good enough. That's really not good enough. So what we can do here is take the constructor function and turn it into a class with a constructor method that still does the same thing as the original constructor function. And so that's maybe progress. Then we can take the invocation of the superclass constructor and turn it into a supercall. So that's a nice syntax that's now available. It's a few characters shorter. We can move the add JavaScript method inside the body of the class, as you're probably used to if you come from languages that actually have classes. And then if you have a constructor that only invokes the superclass constructor with the same arguments, you don't really need the constructor at all. So we can get rid of that and then tighten up some space. And here's one of my favorite parts. We have this pattern of having functions that take options objects just all throughout our code base. And it's really hard when you see that to then go look through the code beneath it and figure out what options are actually used and what they do. So we can use parameter destructuring, which is a fancy word for naming your parameters. So now, instead of a simple parameter list, we have an open curly brace, and then the keys that are accepted by that options object, which is great sort of self-documenting code. And then those properties become local variables. So we don't have to say options.data anymore or options.sourceMap. We just use the names of the properties. So that's a little better. And in fact, there's a thing called object literal shorthand, where if the key on the left-hand side is the same as the identifier on the right-hand side, you can actually omit the colon and the identifier. So you can shorten that up a little bit. And now it's starting to look like, tall and narrow, and like maybe we just put it on the same line. So making progress here. Great. So we still have this exports.js file thing, which is a common JSism, but Ecmascript 2015 provides an even better syntax, so we can just export the class wherever we define it. And the class is still defined in the scope of the file here. It just happens also to be executed. It happens also to be exported. So that's getting pretty good. And the last thing I sort of hoped we could do is maybe reduce the repetition between the parameter list and what's being passed to the push method. But those are really two different things. The first is a list of parameters. The second is a list of arguments. So to show you that those can be different, if we wanted the source map parameter to be optional, you could provide an optional value for it, like null. OK? So made the code a little longer, but arguably better. So this got a lot shorter. We got a lot more white space to work with. And that's not the only metric of code quality by any means. But if you're like me, that feels like a good sign, as long as you can still read the code. So we're pretty addicted to this. And we want you to have the same development experience. We'd be crazy if, having had this experience, we didn't also want to give it to you. Cool. OK, but how? I told you there was going to be an Ecmascript package, and there is. And the way to use it is just to call Meteor add Ecmascript, basically. It's a lot like the existing CoffeeScript package in that sense. You can just add or remove it at whim. And we're confident enough that it's a good idea that if you have an existing app, you can add or remove it, or you can API.use it in a package. But it will be installed by default for all new apps and packages as of Meteor 1.2. So when you say Meteor create my app, it'll just be in the .meteor/packages file as a line that you could remove or look at. So that's pretty cool. That means that going forward, new apps will just automatically have this support. And I want to stop here and say that none of this would be possible this quickly and at this level of quality without a project called Babel, which is the JavaScript transpiler that we are using. So if you haven't heard of it, it's great. Its coverage is really complete, as in the sense of faithfully transpiling what can be transpiled. It's doing that more so than almost anything else. So you should know that this is not all our work. It's largely thanks to Babel. OK, so to answer the question, when somebody presses you, what dialect of JavaScript does Meteor implement exactly? There are a few things you can say. One valid answer is the latest one. In other words, Ecmascript 2015, maybe plus, 2016, 2017, hopefully coming down the pipe. Also, you could say that Meteor implements whatever we can faithfully transpile of the latest version of JavaScript. That's a truthful answer. Whatever will one day be implemented natively, that's the hope. And whatever helps you write your Meteor apps more quickly and with less code. OK, so I want to explain what I mean about writing code that works today and having it continue to work in the future, even if it doesn't work exactly the same way, if it's not implemented the same way today as it will be in the future. That transition from simulated to native support. So what I have in mind are for of loops. You might be familiar with for in loops, but for of loops will iterate over the elements of an array or of an iterator. So you can have a loop like this that iterates over an array and sums up its elements. That'll get transpiled to something like this, which is not code you would have wanted to write by hand, but basically what it's doing is invoking the symbol.iterator method of the array to get back a little iterator that has a next method that it can call repeatedly, and then it keeps calling that until next returns an object with done equal to true, and the value of x in each iteration is that object's value property, right? So this is an example of what's going on behind the scenes. And if you really want to pick nits, the symbol.iterator thing that you see there is actually a special kind of unique property name that really can't be simulated in any way that I know of. So we're just going to have to wait for native support, right? And you might think this would spell doom for for of loops, but it doesn't, thankfully. And why is that? Well, this code assumes not a full implementation of the symbol polyfill, but can make do with a fake one. So this is just a way of making sure that something that looks like symbol.iterator that we use in the same way as we would use the real thing is available. And this would be in a library somewhere that's like loaded before all your other code. And as long as this is there, even if symbol.iterator is actually just a string and not this magical thing, then the for of loops will work. So in other words, the original for of loop works today in translation, although through some fakery. And it will continue to work natively because it's just the same syntax once it no longer needs to be translated. So for that reason, for of loops meet our criteria for inclusion in the Ecmascript package. But symbols themselves don't, even though they are an implementation detail of for of loops. All right. Another example of something that Meteor can do especially well for you when it comes to Ecmascript 16. This is actually more of an Ecmascript 5, the previous version sort of thing. Array methods like for each and map and reduce are now available in literally almost every JavaScript engine, except, of course, older versions of IE8, in particular Internet 8 and Internet Explorer 8 and earlier. And we use or are starting to use a popular polyfill library called ES5shim to implement those methods when they're not available, which is great. We want people to be able to write code that assumes the existence of these methods and not have to be bitten when they go to test their code or when their users test their code in Internet Explorer 8. But there's a catch, which is that there is actually no way to make those new methods invisible or non-enumerable on the array prototype. So why is that a problem? Well, if you ever use a for in loop to iterate over an array, I know that sounds crazy, in Internet Explorer 8, you'll get all those method names too. As an example, here's an array that just has 2 elements at the 0th and 2nd index. So if you do a for in loop, you would expect that the index would only take on 0 and 2 as values, but instead you get things like for each and every and reduce and so forth. So probably break whatever code you're working, whatever code was using that pattern. So normally you'd be out of luck, and you would just have to make that difficult trade-off that you don't really care about for in loops over arrays. That's valid. But you do care about array prototype methods and always having them all available. But this is actually a problem that Meteor can fix for you. How is that even possible? Well, it does this because it can do this because it controls the compilation of your code when you have the Ecmascript package installed. So that sparse array argument of the for in loop can be wrapped with a helper function like the sanitize for in object. And what that might do is, in most browsers, nothing. It just returns the argument, so it's like the original for in loop. But in IE8, and only when the argument is an array, it has the opportunity to return a new object that contains only the enumerable keys. So this is a crazy edge case that you probably wouldn't think about. At Facebook, we wanted to ship some array prototype polyfills, and we released them on the site. We thought it was a great idea. And then only after billions of users used the site in Internet Explorer 8 and earlier, did we find out that there were actually for in loops over arrays in our code base, and they were broken because of this. So Meteor can prevent that problem that even Facebook was bitten by. OK, another example. I think maybe the high bit here is that we are providing a promise polyfill. So if you're familiar with promises at all, that's going to be built in along with the Ecmascript package, as well as set and map polyfills, if you're excited about those. But something that I am excited about, and that may excite you if you've ever tried to use promises with fibers in Meteor, is that if you define a property called promise.fiber, then that will be used to ensure that all promise callbacks run in a fiber. So you can like call your Mongo API or call meteor.call in the callback of a fiber, in the callback of a promise. And that'll just work, whereas previously you would have had to use meteor.bind bind environment everywhere. I think I'm going to gloss over the details of how that works. We're basically wrapping the then method of the promise. Here are also some good promise tutorials if this has piqued your interest about promises. And this is how that wrap callback function works. It runs the callbacks using fibers that are recycled in a pool, so you only ever need as many fibers as there are simultaneous promises pending, which is pretty cool. And even better, you basically never have to use meteor.bind environment again if you are using promises. So if any of that makes sense, I hope it sounds like good news. Something that will be easier to understand without as much context is the question of source maps. So of course, we're providing source maps along with compiled Ecmascript code. So if you can see this code over here, it's using some features like a let variable declaration, a computed property name in the hello helper, and method shorthand. So you don't have to say click button :function open close paren. You can just say click button open close paren. And I've put a debugger statement in here so that the debugger will stop here when you click the button. This is just the basic example from creating a new app. And indeed, it stops here and shows you the code that you actually wrote instead of the code that was mangled by the Babel compiler, right? So that's great. That's the ideal development environment for this kind of thing. And it works great in Chrome and Firefox and Safari. But it doesn't work so well in browsers that don't have source map support, obviously. So what can we do for you there? Well, if you don't have any source maps, first of all, notice that this was line 13. So if you don't have any source maps, you would at least like to be able to figure out what line the place where you stopped corresponds to in your original source file. So this is what it looks like if you're just looking at the raw underlying JavaScript. It's uglier, it might still require some mental translation to imagine how these things correspond to what you actually wrote. But one thing is pretty easy to determine, which is if you look over in the right-hand column, these lines are annotated with the original line numbers, and those are derived from the same source map, but they work in all browsers because they're just JavaScript comments. So you can look over in that column and see that this was line 13 in the original code, even though now it's line 22. So I think that's pretty cool. If you ever find yourself having to debug your code in Internet Explorer 8, you'll hopefully thank us. So we think you shouldn't have to wait for universal native support before using the latest Ecmascript features. Nor should you have to wonder when it's safe to transition from simulated to native support. That's the kind of call that we're in a position to make when it seems like it's feasible to stop translating something and rely on native support. Nor should it be your job to figure out the best way to integrate libraries like ES5 Shem with tools like Babel. And I feel like this is one of the problems with the JavaScript ecosystem today, is that you might try to use these two things together and run into a problem and not have any idea whose fault that is. Is it Babel's fault? Is it ES5 Shem's fault? Is it something about the way that you're using them together? So is it your fault? Well, I don't know. And Meteor can be sort of a place where these solutions accumulate, because we're sticking them together, right? So it's our fault. So you can file issues on our issue tracker. And if we fix those issues, and I hope we can fix those issues, then that will benefit everyone else who needs to use those things together under the umbrella of Meteor. And that's all possible because we provide this complete platform out of the box that includes compilation and packaging and delivery of scripts, libraries, source maps, and other assets, which puts us in this ideal position to make the transition as seamless as possible. So that's sort of why I left my job at Facebook, to focus on that developer experience at a larger scale. There are a whole lot more of you than there were engineers at Facebook. So I think it makes sense to work on an open source project that provides these things rather than doing them just for the sake of a bunch of engineers working at a private company. Then you might be able to start writing code that truly is isomorphic in the sense that it works the same way on the client and server instead of just sort of looking the same. So that's a big deal. I don't know. I guess I'm asking for your ongoing feedback. This is an early preview of the support. It seems like the right thing to do, but
In the list of proposals you had, threading basically, right? Or parallel JavaScript.
yeah. Yeah. There are some things that I think that would count as something that requires native support. And so we would probably be able to provide it on the server sooner than on the client. And it might be a while before it's available everywhere. So we'd have to think hard about whether that inconsistency was worth it and whether the difficulty of teaching those concepts justified the difficulty of learning them. That's not the right trade-off, but yeah. So I'm excited about things like that, but we do have to think about how each of these features actually improves Meteor code, which, to your original question, I think there's a lot left to be discovered there.
More questions?
And we need to use a new file extension
No. This is one of the things that has made this project a little bit easier. You could previously register source handlers using the plugin API for any file extension besides JS, so .coffee or .jsx. And that worked pretty well. It was remarkable how far you could get with that. But I think it's important that this package is now able to transpile just normal JavaScript files. And it's nice that no one has been able to do that yet, so that we're not actually stepping on any toes by making that possible. But it will be possible, actually, if you're really industrious, to remove the Ecmascript package and implement your own version of it that also uses the JavaScript file extension. There's nothing special about it. There's just a new plugin API that is being released with Meteor 1.2, which is one of the reasons it's waiting on that. Anything else?
Question from Slava.
Has the application model become really big because of compilation?
So that is a factor that helps us decide whether it's worth supporting a given feature. So for instance, we are, at the moment, not planning to include support for generators. And I say that with some bittersweetness because I worked on the regenerator project at Facebook, which is the way that Babel handles generators. But it just turns generator functions into a lot of code that is hard to debug if you ever have to drop down into the meat of it. So that's a case where, out of consideration for bundle size, we've decided to wait until we see a compelling use case for that feature in Meteor code. And it is true that there is some runtime code that needs to be provided so that the generated code can do its thing. But whereas if you're just using Babel out of the box, it injects those runtime helper functions into every single file where they're used. We're able to centralize them into a single runtime library So that's like a fixed cost that you pay, and then everywhere those helper functions get used, they get to assume the existence of those runtime helpers. So those are a couple of the things that we're doing to mitigate the not already terrible problem of an increase in bundle size. Yeah?
How much of an effect does the translation have on live load time?
So
Can you repeat the question?
yes, okay, I should be doing that. How much of an effect does transpilation have on live reload time? So we use the same caching infrastructure that we have been using for a long time. So when you change a file, only that file has to be transpiled. And I think in my initial tests, if you were to transpile everything that needed to be evaluated in order for your app to start up, that would take about 20 seconds, which is obviously unacceptable for reload time. But any single file is just a tiny fraction of that, so it's pretty unnoticeable. It's on par with like the delay that the file watching code has already between when you make the change and when it picks up on it. So thankfully, no, not much of an impact. Yeah.
How does the Ecmascript package impact the download size of the Meteor app?
That's a good question.
Repeat the question.
Yes. How does the Ecmascript package impact the download size of your Meteor app? Two things I would say is if that turns out to be your primary concern, we're not forcing it on you, so you can remove it, which is not a good answer. That makes it seem like we're more worried about it than we are. I think the largest part of it, I'm almost certain of this, is the Babel npm package that implements the compiler. So if there are features of that we don't end up using, I suppose there's some gains to be had in like removing parts of that we're sure aren't going to be used. But yeah, it's the download time when you like update Meteor or install Meteor from scratch. So it's not the amount of time that you need to like create a new app or start your server or respond to a request. So I hope that that's the right trade-off to make, but let us know if it's obnoxiously large.
And we have one more question here.
So with the new API, can we have multiple source transformation passes? For example, use ES2015 CoffeeScript?
Yes. Well, OK.
Repeat the question.
Can you have multiple transpilation passes? For instance, CoffeeScript targeting ES2015? Is that what you mean? Unfortunately, for simplicity's sake, I think the answer is no. I mean, I know the answer is no, but let's see. You can have different source handlers for different file extensions, if that's important to you. So you could have like a different source handler for Coffee or JSX versus JS. But if you want to do something other than what the Ecmascript package does for JavaScript, you should probably fork it and publish your own package and then remove the built-in Ecmascript package and publish or install your package instead.
Right. OK.
There's
Yeah.
more questions. Yeah.
Some websites serve different versions of JavaScript regardless of their capabilities.
Yes.
Is this something you're planning to support in Meteor as well?
I think that would be great. And I think if we did that, we would be solving a problem that is very difficult to solve by yourself. That probably involves some kind of user agent sniffing, potentially like sending a manifest of capabilities to the server so that you have multiple HTTP requests at the very beginning of loading the page. And maybe that's acceptable. Maybe if you really value that efficiency and using native support as much as possible, then you'd be willing to pay an upfront cost in terms of page load time. I know that the user agent sniffing technique is something that Facebook did for delivering different polyfills to different browsers. So it's feasible, but for simplicity, it's not going to be the first version.
So we'll take one more question, then next talk. Yeah, go.
Right. Who was first?
JC.
Okay.
I have a question about important modules because it seems like if there is like a new module system how you like export and import stuff in JS, and it seems to be like incompatible with what you are doing right now with Meteor. How does that work?
This is a great question.
Repeat the question.
Yes. So in the example that I showed, we used an export statement. And also in the original code that I was transforming into that shorter code, there was an exports object that I was assigning a property to. And you probably realize that that is a common JS style module system turning into an Ecmascript 2015 style import-export syntax. And the reason that is valid is that the code that was taken from is just Node.js code. Like that's how we implement the Meteor command line tool. That said, we are very interested in providing a module system that is built on top of common JS, but that uses Ecmascript 2015 import-export syntax. And we have a plan for having that coexist with the package variable import-export system. So it's sort of like you could imagine having Ecmascript 2015 modules and then also just your global variable assignments are intercepted and turned into package variables. And I think those two things are orthogonal enough that you can have them both. Your existing code will continue to work. You won't have to like rewrite everything to import a bunch of stuff at the top of your files. But there's enough of a need for referring explicitly to other files using module syntax and importing specific properties that I think that's going to be a really high value thing for organizing your code. But that's not going to be in the 1.2 release.
All right, thanks so much, Ben. All right. Our next speaker is Jeff Schmidt. Really excited to introduce Jeff to you. Jeff is the CEO and co-founder of Meteor Development Group. In an earlier life, Jeff was one of the inventors of audio fingerprinting and raised his first venture capital round at age 20. He was one of the original authors of Miro, the decentralized internet TV platform, which today has about 2 million active users. In 2007, he founded MixApp, a synchronized music listening platform, and in 2010, he was employee number 9 at Asana, where he worked on the Luna application platform. So today, Jeff will be giving a JavaScript State of the Union, which covers Meteor's mission in today's JavaScript environment. So everyone, please welcome Jeff.
Thanks, Alice. Let's see. All the plugs. All right. Well, hello, everyone. Thank you all for coming out tonight. We really have a full house here in San Francisco. It's pretty exciting. I think this is the highest number of RSVPs that we've ever had in all the years that we've been doing Devshop. And I know we've also got people tuning in around the world on YouTube. And hello also to the thousands of you that are going to watch on YouTube later. I really appreciate all of you taking the evening to come and spend some time with me. We've got a great audience tonight, a lot of great developers. And as I was preparing this talk, I was wondering, if we added up the consulting billing rates of everyone watching this talk, what do you think it would add up to? I came up with, I don't know, probably north of $50,000 an hour, something like that. So I understand your time is valuable, and I want to thank each and every one of you for the time we're spending together today. I've got a message for you today, a message that could potentially make a big difference for your career or for all of our careers and the industry. And a lot of you probably know everything that I'm going to say, but I'm going to try to pull all the threads together and show you a picture of where our industry is going that I think is really interesting. Before I get started, though, I'm curious. Why are you all here? I don't mean, why did you come to Devshop tonight? I mean, why did you choose this career? Why did you become software developers? Let's try a show of hands. Who does it because you love the intellectual challenge, like problem solving, learning new skills? Okay, about half the room. That's awesome. How about people who love things? It's the satisfaction and just the finished product. About half, probably some overlap there. How about job security, financial reward, the fact that you can make a lot of money doing this and the world will probably never have enough software developers? A couple, yeah. Okay, some of each. So let me tell you a bit of my own story about a career decision I faced in my own life. Let's see, it was a couple years ago. I guess it was 2011, and I had a choice between two options. Option one is I could go do AI research. Option two is I could come check out this Silicon Valley thing. And you know, AI research had been a lifelong dream of mine, and I'd done some AI research consulting before, and you know, had been a science nerd in high school and had run some awards. And I thought, well, maybe I have a chance at getting into this field and fulfilling this lifelong dream. And I don't know, maybe I could make some kind of contribution that would be significant to the machine overlords coming and destroying humanity. I don't know, but it gets back to that intellectual interest, right? Or I could check out the Silicon Valley thing, and like then, you know, we all know the dream here: make something that millions of people use. Maybe become fabulously wealthy so you can be like Elon Musk and like build rockets to space. I don't know. You can see where my priorities are. So I really thought about this long and hard. I really wanted to make the best decision that I could. So what decision do you think I ended up making? I chose to do neither one of these things. I did something that really surprised my family and friends. I decided to work on JavaScript. You know, my friends were like, JavaScript? Really? You mean that dumb little scripting language that's inside web browsers that Netscape made for people who couldn't figure out Java? The one that Bren and I came up with in 10 days to hit a deadline. The one with really strange variable scoping rules, with this really strange object-oriented programming system based on prototypes instead of classes. It's got this with keyword. It's got a bunch of type coercion rules that make you say what. Who's seen the what presentation? You know, there's even a book about JavaScript. It was the #1 best-selling book on JavaScript on Amazon for a long time, called JavaScript: The Good Parts. And friends, this was a pretty short book. So yeah, I said that JavaScript, absolutely. JavaScript has the potential to change the world. So that got some raised eyebrows, even from the people who think that underwater cat photo sharing has potential to change the world. They're like, you're never going to make with JavaScript. We've got a lot of programming languages, right? Haven't we explored all the territory pretty thoroughly? Why is another programming language going to make a difference? But it turns out that JavaScript is a really special language. Because of some special and unique historical circumstances, JavaScript has an enormous opportunity ahead of it, something that no other language has. So I'm going to walk through this, but you know, the next step is let's take a second to look at the high level of what's happening in application development right now. Things are changing pretty fast in the world of apps. And by apps, I mean software that people use to keep track of things and collaborate with other people. Like the apps that we use on our phone, the apps that we use on the web, not games, not scientific computing software, apps. There's been a big change, even just over the last couple of years, of what we expect. And one way to think about this is a shift from the expectations around websites to the expectations around apps. We all know what a website is. It's got this navigation paradigm that's based on links and forms. I can click on a link, I can fill out a form. And there's a set of pages. I'm going between these pages as I navigate through this site, and I'm doing it all in the web browser. And this is like the whole world of LAMP stack and everything that we built, you know, starting in the 90s. This was what most of the web was for a long time. And then if we think about an app, it's a different set of expectations. What we expect from an app, we're not expecting links and forms. We're expecting the full modern user experience, like all the UI, UX elements that are in our toolbox. There's buttons, there's pop-ups, there's dialogues, there's menus that slide out, there's type-ahead search boxes, there's scrolling maps. And the other thing is, these apps don't really have pages anymore. It's sort of this continuous experience. And one way to think about it is there's no refresh button on these applications. There's not a point where the globe spins, the screen goes blank for a second, and you see a new page. It's like one program that's continuously running. It's an app. Whether that's delivered inside of a browser or inside of on a mobile device, there's been a convergence between those two styles of interaction. And the other thing is we expect these things to be everywhere, not just in the browser. You know, we expect apps to be ubiquitous. I expect that I can, whatever device this is that I pulled out of my pocket, like that I can get the app here. Because the user's bringing their own devices. You don't know, it happens to be an Apple device, could be an iOS, could be Android. But not just mobile phones, we're starting to expect these apps on our watches, on the dashboards of our cars, on our thermostats. There's this proliferation of devices. These devices are becoming ubiquitous that run these apps. If we think about, and this started off a bit at a time. It was kind of like the camel getting its nose under the tent for people that know that metaphor. And I think the first thing that ran on the web that looked like an app was probably Google Calendar. People like, the web was supposed to be this universal library of all human knowledge. That was like Tim Berners-Lee's vision of hypertext. And then suddenly someone put a piece of calendaring software into that universal library. It's like, that's weird. But then it snowballed and snowballed and snowballed. And now basically everything people are trying to make, it looks like this. What's really underneath that idea of an app? They've got a couple of essential characteristics that is really what defines an app technologically. The first is the app. There's two parts now to this piece of software. There's the part that runs down here on my phone or in my web browser, the software that's installed on this device. Maybe it's instantly installed, like in a web browser. I type facebook.com, press enter, and instantly installs this enormous JavaScript application. Or maybe I install it at the App Store. But there's a piece of software at the edge of the network on this device. And there's another piece of software off in the cloud, like some number of cloud services that back this. So this is different from web pages, where you had a server somewhere that's just pumping down HTML. Now there's at least two distinct pieces of software. And the other thing is there's data replication happening. Data is getting replicated from this cloud service down to this device. So we're not sending HTML around anymore. We're sending data. And the data is ending up in a data store on this device. And then the code running this device is querying that local database to render the interface. So it's almost like a master database replicating to a slave database. These apps become distributed systems where the data that's in these cloud services have to get replicated down to every thermostat and car dashboard and watch and whatever else comes up next so that the apps can run. And the other thing is the multiple device support. You can't control what device the user will have. There's always new platforms like watches or Internet of Things sensors. Who knows what it'll be next? And you have to support this bring your own device scenario because the app has to be ubiquitous. You don't control the device that the user is going to use. So basically you've got this. You've got these devices down here. These devices are all stateful. Like the whole idea of a web browser for a while was it was stateless. Now the devices are stateful. They have these local data stores or data caches. And you've got the service up here in the cloud that's replicating data down to all these devices to render the interface. And let me give you an example of an app like this, just to paint the picture. Think about an app like Uber or Lyft or any of these car summoning applications. So you've got a bunch of devices down here running several separate apps that are all talking to a constellation of backend services. So there's probably the app that the driver's using. There's probably the app that the rider's using. There's probably an app in some kind of network operations center somewhere that's showing all the cars across the whole Uber system. And then there's a bunch of services that back this. Like there's probably, inside this app, there's probably an authentication service, probably a billing service, probably some kind of car tracking service, some kind of driver rating service. And all these devices are talking to those services. And the interesting thing is, these devices are being constantly connected. They have a persistent connection. They have the service is tracking every single one of these devices. It's not like the stateless request response architecture that we have with the web. If I call a car on Uber, there's a computer somewhere out there in some underground bunker that's tracking this very phone, this very specific phone. So it can push down all the status updates saying, here's your car, your driver's arriving. Every single device that's out there is being tracked in real time by those cloud services across some kind of persistent connection. Maybe that's a WebSocket, maybe that's HTTP long polling. But all these devices are constantly connected to those cloud services. And they're reporting their GPS coordinates. The data replication is happening down probably over a WebSocket. So this is not specific to Uber. This is typical. Like if you think about Facebook, Facebook also has several apps. There's various kinds of chat and real-time like counts. Most apps you use, modern apps, like this is the architecture that's underneath it. I've been trying to figure out a good thing to call this architecture. One of the things that the term I like the best is connected client, because really what we built is this distributed system of all these different clients, all these different devices, this proliferation, explosion of devices. They're constantly connected to those cloud services. They're tracking those devices. Another name you hear for this sometimes is cloud client. So for example, Gartner, the industry analyst group that advises enterprises on their technology, Gartner named cloud client number 7 on their top 10 strategic predictions of 2015. They also gave Meteor Cool Vendor, incidentally, their Cool Vendor Award, which was pretty cool. So the interesting thing is this is not a little shift. Like from the world of LAMP stack to the world of connected client, this is a huge shift. It's a shift that is on the same level as the shift from mainframes to PCs or from PCs to the web. That's how big of a shift web to connected client is. It's the kind of change that comes along every 10 or 20 years. And it leaves a lot of change in its wake. Because if you think about it, we didn't use the tools of the mainframe era to build PC applications. We didn't use the tools of the PC client-server era N-tier architectures to build websites. And what we're finding is we're not using the tools of the web era, or the tools of the web era are not particularly well suited to building these connected client architectures. Most of our software is written on this stuff. There are millions and millions of developers out there that make a great living, or have been making a great living, building on top of frameworks like this. And the things that all the technologies on this page have in common is that they don't address connected client in any way, shape, or form. The thing that they all have in common is they're based on the idea of a process on the server that is rendering HTML and sending it down to a web browser. They have no notion of a device. They have no notion of a connection to a device. They have no notion of pushing updates. It's entirely based on web browsers, HTML, and a request-response relationship. That's what they all have in common. And when you look at that, you can start to see how big this shift is. Raise your hand if you have enough experience to remember Corba. A couple? Microsoft Foundation classes? Yeah. It's when we're looking in the rearview mirror and thinking about technologies that were absolutely ubiquitous, in the early 90s, before the web came, that we used to build the enterprise client server N-tier applications that were how we ran the world, they sank into the ocean because they were the wrong model. And so the interesting situation in front of us is we have millions of developers that use these tools to make a living. And of those millions of developers, what percentage do you think are going to be asked to build connected client applications in the next couple of years? I think virtually all, because to deliver a good, and like the interesting thing is this isn't just about tech companies. This isn't just about these cool startups, Facebook, Google, Twitter, trying to build these like super delicious consumer applications that have great user interfaces. That's how it started. And what happened is those folks ruined it for the rest of us because they raised everyone's expectations. Now, when anyone pulls out a phone, they're expecting the app to look and feel like Facebook. They're expecting people to meet that standard of quality that was achieved at companies like Facebook by massive development teams, long development cycles, the ability to recruit the very best developers on the planet according to whatever their hiring criteria are. And but now everyone's expected to deliver this because this is sort of coinciding with another trend, which is we're finally making the internet work for humanity. We're at this point where all the different ways, like if you think about a business, every business has to interact with their customers. Used to be the way they did that was direct mail, 1-800 numbers. There are these many different communication points that businesses had with their customers. All those touch points are becoming digital touch points. Whether that's an app or whether that's the kiosk in the airport that you use to check in for your flight. All the touch points that businesses use to communicate with their customers are becoming digital touch points. And every time a customer is having that experience with a business, the business's brand is on the line. It's like, is this at least as good as Facebook? Like, can these people, for this valuable business transaction we're having, manage to deliver an experience that is at least as good as the experience that my children use to share photos. It's and it becomes this existential threat because it's this competitive situation. Like people have to keep up with people's expectations, or their competitors will, and they will look like they can't even deliver a basic app, a basic experience. So it's not just tech companies, it's all companies. And it's not just to save money, which is what most of the information technology investments were in the 90s. People are like, oh, we're going to monetize our company so we can be more efficient and save money. This is about survival. So everyone's going to have to build these connected client applications. And right now, how are we getting those apps written? The answer is we're not. It's amazing. Like if you go talk to enterprise decision makers, you're going to hear, I've got 100 apps that I want to write this year, and I have the resources to write 3 of them because I just can't hire developers. Because it's too hard to hire developers to build these new applications because this is what everyone knows. So there's a huge backlog of apps. Demand's only going to continue to grow. And we have to answer the question, how are the millions of developers that use LAMP stack derivatives going to build the apps that the world needs in the future? So I started this talk by telling you that JavaScript has the potential to change the world. Some of you can probably already guess where this is going. But let's get back to JavaScript now. OK, JavaScript. JavaScript has grown from humble beginnings to probably the most exciting programming language that exists today. Humble beginnings. Well, it was designed in 10 days as a scripting language for the browser. How's that for a creation story? It was a toy, basically. Java was supposed to be the language for delivering apps across all these connected devices, right? Java was supposed to be the language for delivering apps on the web. JavaScript was supposed to be the easy-to-use alternative for non-professional programmers. That was the idea back in the 90s. And for a long time, it was used for 3 things: making things blink, making things scroll, and putting up irritating pop-ups. Like maybe add, making images scroll when you roll over them in like terribly ill-advised navigation schemes. I don't know. That was about it. It had very little in the way of developer tools, very little in the way of any kind of debugger or any kind of tools that you need just to survive to write a complicated program. And it was not taken seriously by basically anyone. But then a really funny thing happened, which was the world's richest tech companies, Google, Microsoft, Apple, Mozilla, they all started hiring the world's best compiler engineers. They went on a hunt. Who's the best compiler engineers? We want to hire them. We want to hire all of them. And once we've hired them, we want to put them to work making JavaScript better. Why? Why would someone do that? And the answer is the browser wars. Everyone figured out, or these big, very wealthy tech companies figured out that the browser was super valuable real estate because people are looking at Google. Google's making hundreds of billions of dollars, or Google is a multi-hundred billion dollar company based on their ability to serve ads against search queries. And whoever has the web browser gets to direct the search queries, or that was the theory, or at least gets to have this strategic influence in some sense over people's experience of the internet. So all these big wealthy tech companies with lots of resources, they all wanted to have the web browser with the most market share. So how do you get a lot of people to use a web browser? Turns out making a web browser that doesn't suck is step 1. And what was making web browsers suck? JavaScript. So what happened was there was this competition to figure out between Google, Microsoft, Apple, and Mozilla, a competition that is still going strong to this day, who could build the best JavaScript runtime. So there was this mandate to make JavaScript really, really, really good, and an enormous budget behind it, and enormous pressure to go win the browser wars and win the market share by making JavaScript really good. And the result is that JavaScript is now the best dynamic language runtime we've ever had. Like, it far surpasses Ruby, Python, PHP in terms of just what JavaScript can do as a runtime. And it's not a mystery why this is. It's just because there have been so many more hours of smart people trying to make the JavaScript runtimes really good. And there's also been this awesome competitive dynamic. It is an incredibly good runtime. And I don't know what else could have produced this other than this like competitive dynamic and all this pressure to like make JavaScript really good. What then happened from there is because of JavaScript, the runtime was so good, it's like, well, let's see where else we can use this great open source technology. So JavaScript got pulled out of the web browser and started being used in more and more places. So we had Node.js. It's like, oh, we've got this great dynamic language runtime. Why are we limited to using it in the browser? And then it's also made its way all over the place, onto mobile platforms, lots of different places. And then The more places JavaScript is used, the more developers learn JavaScript. The more developers learn JavaScript, the more momentum JavaScript gets. The more momentum JavaScript gets, the bigger investments that we can make developing good tooling for JavaScript, the bigger investments we can make as an industry in things like ES15. And so it's this virtuous cycle where JavaScript's just gotten better and better because it got embedded in the web browser. It kind of beat out Java as like the language that was going to be humanity's standard language for running untrusted code. And then once it got there, it just has benefited from this incredible cycle of improvement because developer platforms basically get better at a rate proportional to the number of developers using them. Like the number of hours of developer time that's been spent on something is basically how good it ends up being. Waving my hands a lot, but I think there's a lot of truth to that statement. So let's look at where this leaves us. We've got a language that's really easy to use because it was always designed to be the easy alternative to Java. Like easy is like deep in JavaScript's DNA, accessible to lots of people. It's performant. It's the best dynamic language runtime we've ever had. It's known by a ton of people, so the developer community is there. And it's ubiquitous. It's embedded in all these different devices. All these different devices can run JavaScript. So all this adds up to something really surprising, something that I think very few people would have predicted, which is JavaScript has emerged as the only reasonable language for cross-platform app development. Because first of all, it's the only language that can target all the places you want to run an app. I mean, setting aside the fact that it's not too shabby a language at all. It's like, absolutely great runtime. ES15 is the best JavaScript we've ever had. But even if those things weren't true, it's the only way you can target the browser and virtually all mobile devices, to say nothing of the server, from a single code base. If you use absolutely any other language, you're going to be re-implementing your front end multiple times in different languages to target all the devices you need to target. And that's just a fact. Maybe you don't care about targeting more than one device. Maybe you don't care about targeting both browser and mobile. Maybe you only need one. But the interesting thing is, a whole lot of developers do need to target both, probably the majority going forward. And so what we're going to end up with is an industry standard that lets you target them all. Any technology that can't do that is going to get left out in the cold. And it gets even better. Like, there are actually cases where JavaScript somehow has ended up privileged over the native language. So iOS is a good example of this. If you write your application in Objective-C, or you write your application in Swift, well, guess what? Every time you push a bug fix to your app, you have to go through the whole App Store Apple approval process. You have to go wait 2 weeks for some reviewer to test your app again for the tiniest bug fix. And they might reject your app. It just really depends on which reviewer you happen to get that week. But with JavaScript, JavaScript is the single language where Apple lets you push over-the-air code updates. It's specifically carved out in the iOS license agreement. Well, don't push any over-the-air code updates unless it's JavaScript. Because Apple knew that something had to give, and they said, as long as you run the JavaScript inside our JavaScript runtime, we're going to say, OK, that's all right. OK, so back to this. So what I said so far, connected client. We need a way to write a radically different kind of app than we've been writing, one that works with a large array of devices that connect to these cloud services and maintain these stateful connections between all these different devices that are proliferating and the sources of truth and the coordination services up in the cloud. And the technologies that millions of developers know, like PHP, Rails, Java, .NET, don't let you do that effectively. And then on the other hand, we've got JavaScript, the best technology that we've ever had for cross-platform app development. What if we can use JavaScript to make it really easy and really fast to build apps? What if we could make it faster and easier than it's ever been in any language that's ever existed? And I'm not talking about front ends. I'm talking about the complete app. I'm talking about this whole relationship where you've got the app running down here. It works on lots of different devices. And you also have the trusted cloud services up here. And you also have all the data replication. So not just the layer here that shows things to the user, but the whole app, this thing. This is what we're all trying to build. What if we could make it 10 times easier and faster than it's ever been? That's the potential that I think JavaScript has in front of it. Can we really make it 10 times faster? I don't know if 10 is the exact number. I'm not even quite sure how you would measure that. But something pretty significant? Absolutely. Because when you're writing an app, there's only two things you should really be spending time on. One is setting up your interface. Whether you do that in HTML or native view hierarchies, hopefully it's something declarative rather than writing imperative drawing code like we used to do in the 90s, right? But setting up your views is thing one, and thing two is writing the business logic that's actually unique to your particular app. The actual pieces of code, which are usually pretty short, that actually do the work on your app's various objects when the user does something. Everything else, managing the movement of data, accessing cloud services, maintaining the client-side data store, doing your optimistic UI calculations, your build tools, like everything around scaling your app, that stuff should be seamless. Because if that stuff is properly abstracted, it's actually the same for every application. All that stuff should be part of the platform, like the underlying operating system. It shouldn't be something we're building over and over again for every application. But right now, that's really not how it is. If you think about it, most of the time that you're working on your app, and maybe Meteor's an exception to this, I don't know, I think we're making progress, you're doing something other than writing the parts that are truly specific to your application. You end up building your platform at the same time as you're building your app, only to throw your platform away as soon as you write another app. And the other thing is, often simple things about your app get smeared out over your whole stack when you do this. Who's had the experience of you make some change to your app that like logically is a single change. Maybe you're adding another field to an object, and you have to go change code in 6 or 7 different places because every part of the stack you have to propagate that change through. It's because that's a sign that your platform doesn't have the proper abstractions around it. Your app gets entangled with your framework. And the whole situation is basically like it's 1996 and we're writing web applications in C. It's like, it's possible to build these applications, yeah. You can just look at it and say, this is, when I'm writing C code to parse, HTTP headers, because we just invented the web, I'm pretty sure a lot of that stuff, we're going to find a better way to do it. So if we could really get that, enormous improvement, that 10x or whatever x it is improvement, what impact would this have on the world? It would be enormous. You probably heard the phrase "software is eating the world." I think what that really means is software development has become the rate-limiting step for human progress, or business, if you prefer, of lots of different types. There's a lot of apps that aren't getting written that need to get written. If we could make software development easier, if we could make software development faster, those apps that aren't getting written could get written. And that will make people more productive across the whole world and make the good parts of the future happen maybe just a little bit faster. And it also means that more people can build apps. More people can get good jobs, have a hand in building the future. And last but not least, software developers as a group are going to make a lot more money because we'll be able to deliver more value to businesses, and we'll take home our share of that. Like, it just stands to reason that if we can get those other 97 apps written, that represents not cost savings, but business value that's actually being left on the table because we as a human species can't get the software written, that's going to result in good economic outcomes for the developers that are able to deliver that. So that's the opportunity that JavaScript has in front of us. If we can really pull this together and make JavaScript the language that we use to build connected client applications, most apps are probably going to be written in JavaScript, because that's what works in the browser. JavaScript will be taught in every junior high school. It'll just be, I don't know if it'll be an elective or it'll be a required class, but the first language people will learn will probably be JavaScript. And hopefully what they'll learn is not how to compute the Fibonacci sequence on the first day of class, but how to make an app. It's like that's what everyone wants to do. So we have a chance as a community, as a language community, as the JavaScript language community, to build the easiest to use and most impactful app development platform that we've ever had, right at the point in history where app development is having the biggest impact. Okay, so now you know why I think JavaScript has the potential to change the world. The problem is that so far, despite all the progress JavaScript has made, most of its potential remains just that, potential. That's because JavaScript today is fragmented and incomplete if we think about where it needs to be to deliver that complete app development story. It isn't 10%, it isn't 10x faster than the previous generation of tools, like if you're comparing it to building an app in Spring or Rails or PHP or ASP.NET. A lot of times it's 10 times slower because JavaScript does, unlike those platforms, JavaScript doesn't come with everything you need to build an app. What's some of the stuff you need to build an app? There's a ton of stuff to build one of these connected client applications. Everything from how are you going to get that data down from the server? You're going to need some kind of a wire protocol. probably going to run over WebSockets. And then where are you going to keep it? You're going to need some kind of client-side data store. None of that's in the box. Like W3C didn't specify anything for that. How are you going to get that stuff on the screen? You're going to need some kind of a reactive view rendering layer. And guess what? As soon as you've got that, you make the inconvenient discovery that you can't wait for answers from the server whenever the user takes an action. You actually have to simulate what the server is going to do ahead of time so you can update the UI immediately and then patch your user interface with the result of whatever the server did. So that's optimistic UI. We can just go on and on here. Like there's a ton of just basic machinery that doesn't have anything to do with writing your app that is missing from JavaScript. So what people do is they end up building their own custom stack from scratch for every app they build. And we'd like to hope that that stack is good, but in reality it usually isn't, or not as good as it could be, because you never have as much time to build it as you'd like, and I'll put it this way, you usually end up learning a lot along the way. So building that platform every time you build an app is not an efficient way to build software. And it turns out it's not how most software is built. Something is missing, and that something is called a platform. The biggest thing that's holding JavaScript back today is when you pick JavaScript, you get a language, but you don't get a platform that comes with it. You don't get the complete picture of how to build a connected client app. Instead, you get a bunch of puzzle pieces. The puzzle pieces are from several different puzzles all mixed together. And some of the pieces are missing, and you have to recreate these puzzle pieces. That's the situation if you're out there trying to assemble all these different pieces together and build that. It turns out that most of the software in the world is written on top of a platform. What's a platform? It's a complete, consistent environment that's got everything you need to build an app, all the libraries, not just the language, but also the libraries, an ecosystem of APIs, all put together in one consistent experience that works the same way, no matter what device you're on and no matter what you're trying to build. And all the touch points in those platforms, hopefully, have been designed with the purpose of helping you achieve your goals as a developer. So there's a design, there's kind of an intelligent design element that's happened here in this whole platform. So, most software that's written is written in the enterprise, that just numerically. That's where most of the software lives, even if we don't always see it in San Francisco. And of that software, 80 to 90% of it is written on top of .NET and Java. So these are really the platforms that most software is written on top of. They provide a complete, consistent developer experience. So .NET isn't just CLR, the common language runtime, or C#. There's actually a bunch more around that makes a complete platform. Java isn't just the JVM. It's all the other stuff around Java that makes it a complete platform. So why doesn't JavaScript have a platform? For us to get to the point where we can take this 80 to 90% of enterprise software development, which is a significant fraction of all the software in the world, and move that over to JavaScript, which is what needs to happen to solve the problem that millions of developers have for building connected client applications, we're going to need to come up with a platform. Here's an analogy. It's like people have been driving cars, and they're looking up in the sky, and they're seeing planes, and they're saying, I want a plane. OK, so the cars are classic LAMP stack applications. And the planes are connected client applications that everyone knows they need to build. So you're looking around. There's a lot of shiny new parts, plane parts you can find, like Angular, React. This is like a propeller for your plane. Awesome, I've got a propeller. I'm one step closer to a plane. Well, what's the first thing I do? Maybe I weld it onto the front of my car? OK, so that didn't work. But you're a little closer. You can build planes. You can absolutely build planes. It's not easy. It's fun, maybe, if you're motivated by intellectual challenge as opposed to shipping product quickly. But you're going to need not just a propeller, you're going to need an engine, you're going to need a cockpit, you're going to need some landing gear. You're going to need some wings. Turns out you can't get wings off the shelf. You have to design the wings, so I guess you need to get Aero-Astro Engineering in 30 days, read that book, make a homemade wind tunnel, design some wings. You're not really an Aero-Astro engineer. You just read the book, so if that's terrifying, you're right. So you get this all done, you've got a plane, awesome, it flies, you made it work. Took a lot of debugging, but this plane's in the air, you're so proud of it. Who's gonna maintain that plane? You. You're not gonna be able to call Boeing, and guess what? Your plane's gonna be different from everyone else's plane. So if the industry ever standardizes on a standard kind of plane, you're gonna be stuck maintaining that plane forever. And you also can't hire pilots for your plane because you invented a whole new kind of plane. The controls are in totally different places, maybe even works according to a different theory of flight. That's a lot easier in software than it is in actual planes. What you really want to do is buy a plane from Boeing or Airbus, and where Boeing or Airbus will come and maintain it for you, And you can hire pilots that are already certified to fly that plane. That way, you can spend your time flying, because all the business value comes from not from building the plane. It comes from knowing where to fly the plane. Airlines don't build their own planes. Right. So what's missing is a JavaScript application platform. And my perspective here, probably not a surprise given what you know of Meteor, is I think the way you do this is you start with the idea of we want to deliver the best possible developer experience, and we work backwards from there. Solve for developer experience. So, if I think about what that means concretely, we want a platform that is modular but also complete. So it should be made of small, loosely coupled parts that do one thing well. But at the same time, it should have a coherent and consistent overall design so that when you put the pieces together, they fit together seamlessly. There's no impedance mismatch between the pieces. They fit snugly into each other. And it should be complete off the shelf, so as much work as possible is factored out of your app into the platform. But at the same time, it should give you flexibility. If you want to use Angular or you want to use React, you can do that. And it's not because there's a two-position switch that you can set to either Angular or React. It's because it's made of small, loosely coupled parts, and fundamentally the architecture is correct to let you do that. So that's where Meteor is going. We are trying to build a complete JavaScript app platform focused entirely on developer experience. So this is a big project. I have a friend who has a theory about software platforms. He says, never seen a software platform built in under 10 years. Whether that's a database or whether that's a programming language. This is a big endeavor, and it's an endeavor that includes everyone in this room and everyone in the JavaScript community, because there's work to do to put the platform together, but the platform is actually made of a ton of pieces, most of which are made by people all over the world. So there's a ton of work for the Meteor community to do. There's a ton of work for the broader JavaScript community to do, for us to get to this point where we can have a complete platform for building connected client apps on JavaScript that will let the millions of developers that are on LAMP stack derivatives migrate forward into the future. So lots to do. How are we doing? Well, GitHub stars don't actually mean anything, but I do think it's pretty interesting. Bit over half a year after Meteor 1.0's release, we're up to the number 10 top starred project on GitHub, right below Rails. And when I say right below Rails, I don't mean by a lot. We're talking a couple hundred stars. So how is this thing that's just hit 1.0 catching up to Rails? This is how big, and when I say number 10, I'm counting free programming books and some other things that are further up this ranking. This is how much we need this. This is how much demand, how much curiosity, how much eagerness there is to solve this problem of how we can how we can move from all the LAMP stack derivatives we've been building on and move to something that goes with this era of computing. JavaScript. Have we changed the world yet? I would say not yet. Changing the world requires a movement. We all have to do it together. So I hope you'll join this movement. I hope you'll help us in whatever way you can, help to build the JavaScript app platform of the future, so that we can solve the problem of how are we going to build all the apps that aren't getting built that we need. So thank you.
So we're running a little bit behind schedule, but we'll take a couple questions for Jeff. So I think you in the back, put your hand up first.
Hey, thanks for a really good talk. My question is, what's your confidence level in Cordova to be able to build high-quality mobile experiences? And will MTG be investing further in Cordova?
So the question is, what's our confidence level in Cordova? I think that we will be continuing to invest in Cordova and PhoneGap. I think that's an important option in how you're going to build hybrid mobile applications. And I think, if you look at, sometimes people get turned around and they think, they ask, do things need to be fully native? Do things need to be something like React Native to make forward progress? The answer is, if you look at the guidance, for example, that Gartner is giving the enterprise, they say use JavaScript for your mobile applications. There's going to be a couple applications that, I think Forrester's, and I'm not sure I can quote, but there's going to be a couple applications that need the AAA, excuse me, high quality experience. You can afford to have 3 different teams that are of specialists building the 3 different instances of the front end. But I think JavaScript on mobile is here to stay, and I think Cordova and PhoneGap is the leading option right now. I think when we think about the future, there's some really interesting stuff that's going to happen, because I think if I can gaze into the crystal ball, and I just want to say that this is totally speculative, I think React Native is an example of a really interesting direction that we're going to see a lot more of, and that is using JavaScript as the programming language on mobile, but not using CSS as the layout engine, because JavaScript works great on mobile. Such challenges as you face are around the fact that we're using the rest of the web browser, which is really not what we need. Like, we can use JavaScript to drive the native view hierarchy just as fine, and using something like a good JavaScript app platform should let you write code that's reasonably agnostic of whether your app is backed by a native view hierarchy or an HTML view hierarchy. So I think absolutely thumbs up, go build Cordova PhoneGap applications. That's a great technology that has a lot of support in the industry and a lot of support from us. We can't be everywhere at every point all the time, so we won't always be able to fix every issue immediately. And going forward, I think there's some really exciting stuff coming down the pike. But really, is that coming in a year? Is that coming in a couple of years? I think I would take a wait and see attitude there, because there's the first thing that comes on the scene may or may not ultimately be the solution. I hope it will be, but we as an industry will probably learn a lot. Next question.
Great. You in the pink.
Yeah, so we know Meteor is very good to make an MVP, right?
Mm-hmm.
So what's the scalability, as a company, right, with the selected platforms? We hope this will be able to become at least Facebook, as you mentioned, in the long run. But if we, spend a lot of time to work on, in the media, and later on, we know after a year or 2 months we need to change, because when the user comes in and to use Rails or do something else, then that is a lot of time. So what's your opinion, or what's your plan, or what's your thoughts about scalability and support of large scale deployment of media?
What's my point of view on Meteor scalability? So the question is, if we have an app that we have high hopes for, and we have a big market for. So it's not just an internal app where I would be totally satisfied if this serves the 20 people that need it, but I potentially want to serve the whole human population, potentially want to get to Facebook scale. Can Meteor do that, or is Meteor just good for the MVP? So there's a couple things to dig into here. So on scalability, you're never going to get to Facebook scale without a lot of engineers doing a lot of work. When you talk about that number of simultaneous connections, nothing ever does that off the shelf. But we've had. I'm very pleased with what we're seeing with our production customers that are using Meteor in terms of how far the experiences they have with scaling. I think the biggest place where the platform should improve around scaling, I guess there's 2. One is around better tools for visualizing what's happening inside your application in terms of which queries, like which observes are fast and are slow. I think that's really an area where we can improve, and as a community we'll continue to improve, because without that visibility, if you can't tell which queries are slow, that's like probably the biggest challenge, like the difficulty in understanding what the hotspots are. So I think that's a challenge. The good news is when you dig in, if you maybe have to roll up your sleeves and write some of your own instrumentation, you can figure it out. The other side of it is I think that in the end, scalability comes back to your database with Meteor. So the question is Mongo going to get you where you're going? It has worked really well for a lot of people. Another thing that will help a lot as far as the making the platform look more conventional from a scalability point of view is SQL support, because that opens up a lot more options in terms of the databases that you can run your app on top of. That said, though, I'd be happy to talk offline more about the experiences that we're seeing in production with Meteor on top of Mongo, which are encouraging. There's another axis, too, which is app complexity. This is another place where I think we have some work to do. So we should be providing more guidance and more patterns in the core framework about the right way to structure a large application. Like 1 developer working on it, great. 5, no problem. 10, okay. I hope you have good internal coding standards. 100, if you had 100 people all working on a Meteor app, you'd start to run into challenges just in keeping your app well structured. So a big part of this is because I think we need to, there's a ton of packages out there that are great that you can use to build your application. The more that we can do as a community to start assembling that into a standard set of packages so that everyone knows, oh, this file goes in this place, or this is the right way to set up your methods, that'll make it a lot easier for some of the other things that you might not think about when you think about scalability, which is scalability of your code base and your development team, so that if you hire a Meteor developer, they already have the same ideas about where to put the files. So I would see that as another area for improvement going forward.
Cool. Yeah, I'm sure a lot of people will have more questions. In the interest of time, I'm going to end Q&A here and give Jeff another round of applause for a great talk.
Okay. Thank you. Thank you all so much for coming. I'm here because you are. Thanks a lot.
All right, so we're not done yet. Next up, we have some great lightning talks. You can see the lineup at lightning-talks.meteor.com. First, we're going to take a short 5-minute break. If you're speaking, please come backstage, and Sam will help you out here over to my left. Everyone else, go ahead, stretch your legs for a couple minutes. I'll see you in 5 minutes.
Devshop.
Yeah, I pretty much. Yeah, it's like more, but this light tells a lot.
Yeah, pizza.
Yeah, that's
Cool. Excellent. Yeah, no, it's our first time back in SLL.
Oh, nice.
So we're like, oh, let's go to the entry, you know, but
That's good. That's a good campus.
we're enjoying it. We're going to Hawaii, so hopefully, you know,
Where are you going?
pick up.
Okay, I'm going there for 2 days. August. August 5 to. There's a shop that like.
Also,
Funny.
you're going to Wednesday, right?
Yeah, I think so. Yeah, I'm flying out Saturday.
We're on Hero side of volcanoes first, and then
I'm staying on the Coast side, so I'll probably drive straight to Yeah, I've been there once and I didn't see the volcanoes.
yeah. Cool.
Cool, see you then.
That's something you want to be able to say.
Yeah, really. I like that. Should I? Oh, is that the only thing we're watching? Yeah. Okay. Yeah, okay, cool. All right, if everyone could take a seat, we're going to be starting lightning talks in just a few seconds. No, it's all right. All right, so if you're in a conversation, start wrapping that up and finding somewhere to sit down. Rahul, you're up first. Do you want to set up while I crowd people?
Yeah. Help.
坐的太前面了，太入了。
All right, yeah, welcome back, everyone. Welcome back. All right, so I'm pleased to kick off Lightning Talks. We have 5 really interesting talks lined up for you today. And first speaker is Rahul Chowdhury, who will be speaking about Tesloop.
Okay, hello. Can everybody hear me? Is everybody ready? Cool. Maybe we should close that door over there. All right. Okay, so kind of off the back of that energy that Jeff's talk just generated, I'm having a little bit of a problem speaking slowly. I had 4 cups of coffee. So one of the things that he focused on that I really liked was this slide of 10x, easier and faster. And that's like a key of Meteor that I've always focused on. So I figured I'd give you a short talk that showed you how an example of how we've used Meteor to do things 10x faster and easier, roughly. So this talk is about a company called Tesloop. And what's Tesloop? So I'm going to let a 16-year-old explain it to Elon Musk. Without ads.
My name is Hayden Sonad. I'm a shareholder, and I'm finishing up 10th grade tomorrow down in LA. And one of the really things that I've noticed about the majority of Teslas is that they're really not being utilized too often. They mostly just sit around with, they just mostly sit around. So what I've been able to do, due to some pretty fortunate investments, I've been able to order an 85D. And what I really hope to do with this car is use it to its full potential. And I'm going to be doing this I'm going to be creating a constant loop of this car with constant people filled in it, and it's going to be going between Culver City and Las Vegas. And I call this a Tesloop. And
Okay.
And by doing this, I assume I can save around 40 tons of carbon dioxide emissions into the air every month by these cars. So my question is mainly about, thank you. So my question is about autopilot in version 7. I want to know that if I do lend out the car for people to drive it from LA to Vegas, if autopilot will be good enough to really ensure their safe travels over the road. And
so he just kind of keeps going from there, but the core elevator pitch happened. So everybody in this room, including me, because I was there, was kind of thinking like, who's this kid? What is he doing pitching his startup to Elon Musk? And at the same time, well, he's 16, so maybe he should be pitching his startup to Elon Musk. Well, so as it turns out, and I didn't know this was my customer. We had already spoken, and we were going to do some work together. So what did we do?
And on the highways. But
let's figure out a way to get to the next slide. That's great. We built this app, the Tesloop booking UI, which is a mobile app, which you can see is kind of getting used here. It's very simple. It just allows you to pick a date between a pre-established route, scroll down, follow the terms and conditions, and pay for the trip, which we'll see shortly. So that's the whole thing. We did this in a system that we call jumpstarts. So that's a business model that we use with some of our customers where we build software in a week. And part of the reason we can do this is because Meteor exists. Jumpstarts are a thing where we spend exactly 1 week, 5 days with a customer, usually with 1 or 2 devs. And we're very explicit about fixing cost and time and varying scope. And in this specific instance, it was myself, Q42, and Sam Hatoum, whom many of you may know from Velocity Framework, who went down there and built this with them. And if you have been paying attention to Meteor this week, you may have noticed the blog post which we wrote. So if you want to know more about it, recommend going and reading this blog post or visiting this website. Thanks.
Do we have any questions for Rahul?
What's your weekly rate?
What's my regular rate?
Weekly rate.
A weekly rate? Yeah. You think I'm going to tell you that on a live broadcast on YouTube? This is where Jeff said, let's talk offline.
Question over here.
Was that Stripe checkout in a Cordova app?
No, so that was actually me running it in Chrome with the setting that previews it as a mobile app. And right now it is live as a mobile app, but as a mobile website that you can view through your browser. But it's very trivial to add Cordova support. You just go to the command line and say add Android and iOS. The reason we didn't ship that is because there was some decision making with the customer about prioritizing doing that versus building something else, and we ended up choosing that thing.
But it was Stripe?
It was, yeah, that was actual Stripe. That was live. Yeah.
We had a question in the back.
How did Elon Musk respond?
Well, you heard him say one thing, and it was kind of a deadpan, okay. So he kind of started off with that because that was sort of like, that was the feeling the room had, which is, this happens a lot at Tesla shareholder meetings. People try to get work at Tesla. But luckily, the conversation was changed from my startup pitch into a question about autopilot. So Elon went with that and gave like a 10-minute answer about autopilot, which was sort of interesting, I guess.
Question
Sorry? So I'm sorry, I can't tell what you're saying. So is it a car sharing app? Yeah, it's sort of like an alternative to taking a bus or taking a flight. You get in the back of a Tesla Model S that drives between, for instance, Los Angeles and Las Vegas.
But why just Tesla? You can basically share any car. Or is this kind of tied to this car?
Well, so the way it works is just like with a flight, somebody is operating the plane. In this case, somebody is operating the Model S. You book a seat in the Model S, they take you somewhere, and they drop you off. There's not car sharing in the sense that somebody has their car and
I think the
can
question
have
is
someone else.
why a Tesla in particular, not?
Why a Tesla? Oh, okay. So why a Tesla? Because, and that was kind of like why they... Yeah, it does. But this startup specifically is focusing on this idea of having Teslas drive around because it's sustainable. It runs on top of Tesla's supercharger infrastructure, which makes charging free. It's a great car. It's very luxury. And they can do it very regularly. They can just have them driving full time. So that was kind of the idea behind the startup.
Great. Any other questions before we move to the next speaker? All right, thanks so much, Rahul.
Thanks.
All right. Next up, we have Dan Daskalescu, which some of you may recognize as Dan DV from the internet. He's going to give a talk called Prior Art.
From the internet. Hey, everyone. What's that in internet slang? OK. So that is my name, and I would like to start with a show of hands. Who uses Gravatar? That's about 75% of you, and I'm one of you. Because Gravatar is pretty nifty, you don't have to upload your picture all the time. Now, who knows about Gmail sub-addresses? Far fewer. OK, so this is a useful takeaway from the talk, all right? Basically, if you have a Gmail, you can add anything after your name, and it's a free alias. You can use it for filtering, for spamming, well, anti-spam, I mean, don't spam. So I use plus Meteor for all Meteor stuff, which means I can filter easily all my Meteor work into one Meteor label. And also, Gmail lets you add dots to your email, which don't matter, so you have a bunch of aliases. And there are more providers like that, including Fastmail or Google Apps for Work, which is the domains you used to get. The problem is that most things online that you can sign up for do not know about these sub-addresses. For instance, this is Segment. If you sign up to Segment with this email you see here, which is my company, I do recall, you will get this awesome Gravatar, because Segment doesn't know to normalize your address. So this is our company, and we want to be a bit more friendly than Segment when people sign up. So obviously, we have normalized email addresses. And this seems rather simple. You just throw in a regexp. But actually, if you think a bit more about it, it's not that simple, because Yahoo doesn't use plus, they use minus. Some domains don't support plus at all. Some use equal sign. Google Apps for Work has domains that you do not know about. Like idorecall.com, you don't know if that's Google Mail or something else. So, OK, let's see if there's a library for that. So I went on GitHub and searched for libraries. And I only found one. And I found a bug on it within the first minute of using it. So, OK, cool. We have to write our own. But that's a good flow. First you search, then you reinvent the wheel. So at least I didn't create yet another package that fixes that. But now that we did create this wheel, which is very, very round and does support many domains, I thought, OK, what if I actually write about what I've learned from these other libraries I have researched? So I listed there 3 libraries that we tried to use before and how ours is different. And this is called listing the prior art. And prior art comes from patent law, and it means basically anything kind of similar that you must show is not too much like your patent to be granted one. So here's one big takeaway, besides don't reinvent the wheel. If you do reinvent the wheel, please mention the prior art, because very few mention. This is a GitHub search of comparison with X. Only issues that I have filed, only in the JavaScript ecosystem. And there are 108 of them. So I imagine that this problem is very pervasive. And here are a few reasons why you should mention the prior art. First, it shows that you have done your research, which means if somebody looks to compare your package with others, they should choose yours because you know what they're talking about. Then it also helps the users pick among many packages that are out there. And you yourself can learn, if you do your research, from what others have fallen into, traps or APIs or best practices. I'll use 1 minute more because people don't ask questions. No, historically, it's my fourth talk. So here are a few better wheels that we invented that I do recall. And one is this normalization thing that supports pretty much any domain you can imagine. Another is a referral system. Again, we didn't find a good one on Atmosphere, so we wrote our own. And I'm going to show you how that works. And another one is a selection menu, which is kind of like Medium. You select stuff, and there's this menu that appears underneath. Doesn't work in this because it's an iframe, but I'm going to show it separately. So that's a menu that pops up whenever you select text. And what's interesting is that it moves around if there's not enough space for it. So that's a distinguishing feature, which we do mention in our prior art section. So back here, this was our last wheel that is very round, and I'm out of time. Happy to take your questions.
Anyone want to ask a question, prove Dan wrong?
Yes, all of these are open source and MIT licensed.
All right, thank you, Dan.
Thanks, everyone.
All right, next up we have Troy Doe. Troy is CTO at HomeGame, and he's going to show us HomeGame, a smart real estate agent app.
Hi, everyone. I'm here to talk about HomeGame. HomeGame is a real estate agent platform app that I built for my client and also get equity out of it. So my name is Troy, and I'm a designer, developer, and marketer. I do Swift, Meteor JS, design, and then market it. I have okay, let's go. I have another company. I have two companies. One is HLab, it's a mobile consulting service. Another one is Swift Mission, it's a 8-week Swift development bootcamp. We turn smart people into Swift developer so they can know both Meteor and Swift. So HomeGame, let's talk about HomeGame. HomeGame is a real estate agent platform including 4 different apps. It has a mobile app. That's the IP address. You can check it out. And then it also have reporting web apps. It also have Julia web scraper. So we scrape the Julia database once a week. So we always know exactly what house on the market. And then the last one is a notification mobile apps. So we push notification to mobile user, so they would know when the open house is going to happen. So I'm going to show the demo of the app right now. So this is the app. We have how to do it. You start with a search. You can search for a house. Let's say this street is 10th Street. You can find there's one house for sale here in 10th Street. It's 331 10th Street. You can add it to your listing. Okay, it's already on my listing. Come back. So the open house start. You can start open house. Include people who show up at the open house. So I just I just create a new lead. So what we do is we help to find all the houses that are similar to the house that the person show up using an algorithm to based on the pricing and number of bedroom in the house. And then you can select, so it suggests the house that has the same pricing as the house that the person went to. And then you can select the house. Oops. Okay. All right, so yeah, that's home game. It's a pretty interesting app if you are a research agent. If you're not, then we have a consumer app coming soon. Thank you.
Do we have any questions for Troy? Everyone's going to wait for the consumer app. Yeah,
Compare with the traditional, the home apps. For example, at Redfin, you can select multiple houses you want to see, and what I do is just at those houses, somebody's gonna call me and just show me. So they call it a floor agent. So what's the difference between your app versus the Redfin? Because Redfin actually, I think they're escaping the MLS, which is the standard database that all the agents are using. So they're more accurate, and you're escaping truly. I assume they're the same, but what is your unique advantages over those traditional apps?
So for home game right now we're scraping Julia mainly to seed the data, but eventually we want our agent to become like Uber driver who actually input real-time data about this house. A lot of these database actually have not updated data. Normally it's a couple months or maybe years updated. So all these agents, they actually in the local neighbor, they actually can update the data. So we eventually give you a better database than all these MLS listing can provide. And then that's our business model. We're going to sell the data to investment companies.
Question here?
Are you literally scraping Trulia or consuming their API? And if you're scraping in it, are you doing that all in JavaScript?
Yeah, so there's a web scripter that written in JavaScript that check Julia website. Right now we only script San Francisco once a week. And yeah, so we don't use the API. The API is very restrictive, so.
Yeah. Cool.
Any other questions?
How often does their UI change?
So the question is?
How often do you have to change the script that scrapes Trulia?
So right now, I don't have to change the script since we started 2 months ago. And then it's still working really well.
Any other questions? All right, thanks very much, Troy.
Thank you.
All right, next up we have Aaron Camarada. Aaron is the Chief Creative Officer at Void Alpha. You may have seen his interview on the Meteor Club podcast recently.
Mm-hmm.
And he's going to be giving a talk on multiplayer gaming with Meteor.
Yes. Hello, gang. Let's see if we can get this. Oh, I guess I should log in. There we go. Oh, it's going to do this again. All right. Come on, baby. That's a little better. Okay. So yes, hello everyone. Aaron, the Chief Creative Officer at Void Alpha. We're a gaming studio over in Emeryville. And what I wanted to show you today was a short demo that I built. I've given talks before on how to integrate Unity, which is a 3D gaming engine with Meteor, which does some very cool stuff. But recently I got an email from the folks at Meteor Montreal. They were playing with an engine called Pixie.js. It's a sprite engine for browsers. And so about 2 weeks ago, I started writing a demo. And so why don't we check it out? Let's see. So if you want, you can go to demo.voidalpha.com. Of course, there we go. Demo.voidalpha.com. And you can go there now. It is a demo. This is why I wanted to go to the slide. It's a demo, and when in doubt, refresh. It's pretty good about fixing itself, but you will find bugs, and it lags. But what's neat about it is it's a multiplayer match 3 game. So here it is, and oh, now nobody's going to play with me. Come on. So what you do is swap tiles to match, line up 3 in a row. Ah, thank you. Yay, we get to watch someone. There we go. So, of course, we're doing a simple Meteor call to do all of the moves, and the server is the authoritative data source. So if there's a conflict, like 2 of us try to move something at the same time, the server makes the call. And I left it this way. It's kind of interesting. There's something in here that's quite wrong, which was alluded to in some of the earlier talks. This does not do optimistic UI. If I make a switch, you'll even notice there's a slight delay. If I click on that, you notice it's like a quarter of a second before it does it, because I actually wait for the call to come back, which is wrong. I had it almost working where you would start the animation locally, which of course is the correct thing to do, and then wait for the call to come back. But again, this was about 1 week of my time, nights and weekends. What we have done before, this is really sort of something to give back to the community. Previously, I have, as I mentioned, I gave a talk on integrating Unity with Meteor. If you want, you can go to ump.voidalpha.com. That's Unity Meteor Pong. And you can play the game, but towards the bottom there's a blog post. So if you want to dig into actual code, lessons learned, and how it actually works, you can get down to the gory details, which has 2 links at the bottom that have the actual code that you can put into your Unity and Meteor clients to get those 2 to talk. I'm going to do a similar blog post for this, but it's not done yet. But I did one last night for Meteor Atlanta, and Montreal had a meetup, and so I kind of Skyped in with them, or we did a video screencast. And it is online now. So if you go to YouTube and search for Meteor Gaming Talk, I'm proud to say that the top 3 results are mine at the moment. And the one from last night is the top one, Meteor and Pixie.js Gaming Talk. It's about an hour long, and it goes into the code behind the tile matching game that you just saw, and so on. But for the lightning talk, I just wanted to kind of put it out there. And if anyone's curious, email us, and we'll be happy to help. So that's it.
Questions for Aaron? There you go.
It is. The question is that all Canvas? The challenge that was sort of handed to me through email was, I think I'm going to mispronounce his name, Robert Persaud, I think. Anyway, from the Meteor Montreal, he kind of mentioned this engine, and it's a 2D, it's a WebGL renderer, and it falls back to Canvas. So in your code, you say, find me the renderer that works best for the browser that I'm in, and then you don't worry about it. In the one that you saw, it happens to be Canvas. Yeah. So, other questions, or? Yes?
So does the optimistic UI create a whole unique set of issues around gaming, right? Because you may not...
A little bit. The question is, does the optimistic UI create specific issues around gaming? I will say what I ran into, rather than sort of answer it in the most general case. I had it where, once you start a swap, the client will do the swap, make the call and tell the server, hey, I'm making this, I think it's legit, do you think it's legit? And then you have to sort of deconflict that, which I had working for me. But then to get everyone else to see my swap, that was when I flipped over and said, you know what? I should be using Meteor to do this. Meteor collections do this. And so when I make a swap and the server says, yes, that's a legit swap, it actually uses collections to pub sub that out. And now, as a player, I get that subscription change. I get the changed event. And now I have to say, wait a minute, that was my change. So now I don't want to apply it twice. So in that sense, it was a domain-specific problem, and it was starting to get to be hairy code, and I knew that the right answer was to pull it out, and so I ran out of time, basically. Yeah. So, okay.
Right.
Oh, yes.
Do you have a plan to test like how many players can run at the same time?
The question. Right, question about optimization and player testing, load testing. No plans. Again, this was a proof of concept demo. It works for 2. I've seen it work for 8, but after that, I would not use, again, I would use Meteor for things like the leaderboard over on the left, which is reactive, inventory in an RPG, but the real-time stuff has to be through something other than Meteor. So use the technology for what it's good at and not the stuff it's not good at. So, all right, thank you.
Cool, thank you so much, Aaron. All right, last but not least, we have Robert Dickert. He's a community engineer here at Meteor Development Group. I know many of you watched his talk earlier this afternoon. So Robert's going to give a short talk on how to set up Sublime and Atom for ES 2015 and JSX.
Okay, so a quick poll. How many people know what linting is? Pretty good. Okay, how many of you are using linting day to day in your coding? Okay, somewhat fewer people. Let's talk about what linting does, and I'll show you what it's easier just to show you what it is, but linting is a way of having your editor show you mistakes that you might have made. So it'll catch errors right away, it'll help make your code consistent, and it'll help you follow best practices. So let's just jump into what linting looks like, because I think, so here we have a line of code where I've left off a parent, and it has flagged the line as being bad. So that helps me to find bad code. You can also do it for stylistic things like semicolons, or if you want to remove trailing white space, that sort of thing. You can set all those kinds of flags. So I'm going to fix that. All right, cool. Oh, wait, something else has appeared down here. Oh dear, this is a problem because this is a JSX file. This is React code, and we have an HTML tag in the middle of our code, which is not acceptable to normal JavaScript. So we need to change how our linter is set up in order to handle that. So what should we do here? So what we should actually do is we're going to have to change the way we have Sublime or Atom set up, or anything that you're using. But I have help for you if you use Sublime or Atom. And for Sublime, I'm just going to point you to a blog post that I did. It was just a couple days ago on the Meteor blog, and you can read the directions there. The basic story is that you're using a couple of node packages called ESLint and Babel for syntax highlighting, and then you just hook up the correct packages in Sublime. It doesn't take very long, and there are directions on the blog. But I also want to give a quick shout out to Chris Wessels, who suggested looking at it for Atom, because it's almost the same steps, it's just some different packages. There's going to be a follow-on post for that, but if you are using Atom and you want to do it right away, these are the packages you'll need to use: language, Babel, linter, and linter, ESLint, and you have to set a couple of configs, which are to use the global ESLint, and I had to set my global node path in order for it to work, and then restart it, and it all works. So that's it. I hope you will think about using linting in your code editor, and if you want help, check out the blog post. Thank you.
Yeah, questions for Robert? We can't take.
All right, awesome.
Any questions for Robert?
Oh.
Can you tell us a little bit about Electron?
Oh, about Electron. I actually don't know a lot about Electron. Isn't that's for
It's the shell of Atom. It's really awesome. I use Linting too.
All right, so we have a plug for Electron, which is the shell which runs Atom, so you can build apps in JavaScript, native apps. Any other questions? Okay, thanks.
All right, thank you. Wow, that was incredible. Thank you so much to everyone who spoke. Thank you everyone for being here and being part of this awesome event today. So if you're watching online right now, please subscribe to be notified of new videos and Devshop Live events. You can rewatch the live stream from today anytime, and we'll also be posting all of the talks as individual videos soon. We also upload talks from Devshop London. We have an event very similar to this one that happens in London every month, so definitely subscribe. Keep an eye out for those talks as well. So our next Devshop is already up on meetup.com. You can RSVP to it. It's Thursday, August 27th. In general, our events are the last Thursday of the month. We've got 2 Meteor production case studies that we'll be highlighting as our featured talks. So one will be about Hansoft. It's a workplace collaboration tool for agile teams. The talk is called Building a Blazingly Fast Productivity App, Sharing 98% Code Between Web and Mobile. And the second talk is about Grove Labs, which is a company that builds these advanced automated home aquaponic systems. And their talk is about building Grove Labs using Meteor and React. So please RSVP on Meetup and save the date for that. For all of those, for all of you who are here in person, please help us clean up. This is an especially large event today, so please help us with the trash. Gather up and throw away any trash that you can find, and help us stack the chairs in the back corner would help us out a lot. So yeah, thanks so much. We have still some food and drinks left, so feel free to hang around until we start playing the closing time music to nudge you out. But until then, please enjoy yourselves and please enjoy our event space. So thank you, everyone. See you next time.